This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 10, System Integration. This is the synthesis lesson that ties the whole course together. Every air conditioning system answers one question. What carries the zone's heating and cooling load to the space? All air moves it in conditioned air. All water pipes hot or chilled water to terminals at the zone. Air-water splits the job. Primary air for ventilation, water for the sensible load. That single choice drives duct size, pipe size, how you deliver ventilation, and whether an economizer is even possible. We'll pull Week 4's air side and Week 5's water side back together. Concept 1. The classifying question. Ask one thing of any system. What medium delivers the load to the zone? That answer splits the whole course into 3 families. All air carries the entire load in conditioned air, constant volume reheat, VAV, with big ducts, and ventilation and economizer come along for free with the air. All water pipes hot or chilled water to zone terminals, like fan coils, with small pipes, but ventilation has to be delivered separately. Air-water splits the job. Primary ventilation air plus water terminals, induction units, chilled beams, or a fan coil paired with a dedicated outdoor air system. The 3-way taxonomy is a teaching frame, not a handbook heading, but it decides everything downstream. Concept 2. Read across the 3 families. Same zone load, 3 ways to deliver it, and each buys a different trade-off set. All air carries the load in conditioned air through large ducts. Ventilation is built into that air, and an economizer is easy because you already move a lot of air. All water pipes the load through small pipes to fan coils, but ventilation needs a separate path, and economizing is hard because there's little or no air path. Air-water splits it, small ducts and small pipes, with the primary air serving as ventilation. Read this as the map of the whole week. Week 4 built out the all-air side. Week 5 built out the all-water side. Concept 3. All air. Here the central air handler does everything. It conditions the air, and that same airstream carries both the zone load and the outdoor air ventilation. That's exactly why economizer-free cooling is easy on an all-air system. The ducts and dampers to pull in a lot of outdoor air are already there. Behind every all-air terminal is the central component train, the mixed air section with outdoor, return, and exhaust dampers, filters, heating and cooling coils, a humidifier, and the supply fan, with draw-through versus blow-through set by where the fan sits. The mixed air temperature is just the flow-weighted blend struck at that mixed air section. Concept 4. Air-water. These systems separate the 2 duties. A primary air unit, a dedicated outdoor air system, or DOAS, delivers the ventilation, while a water terminal at the zone, a chilled beam, induction unit, or fan coil, handles the sensible load. In the schematic, the light blue path is ventilation air sized for people. The water loop below is decoupled, carrying the zone's sensible load. The payoff, you size the air for the occupants, and the water for the load, and small primary air ducts plus small water pipes beat one set of huge all-air ducts. Chilled beams and induction units are the classic air-water terminals. Concept 5. A worked read on the air-water changeover temperature. For an in-room terminal system, the handbook gives the outdoor temperature at which a zone's secondary water must switch between cooling and heating. Plug in the givens. The primary air term comes to 4400, the numerator to 1400, and the changeover temperature works out to 68 degrees. Below that, this zone wants heating. Above it, cooling. In a 2-pipe system, the whole building flips at one changeover temperature, so a zone needing the opposite mode simply can't be satisfied. Traps. 5 ways this bites. 1. All water fan coils still need a separate ventilation path, because a fan coil recirculates room air and doesn't bring in outdoor air on its own. 2. Air-water decouples ventilation from zone load. The DOAS does ventilation, the water terminal does the sensible load, and sizing them independently is the whole point. 3. Economizer-free cooling is easy on all air, but hard on all water, because an all-water system has almost no air path to economize with. 4. The changeover temperature is where a 2-pipe system flips heating and cooling. One water temperature serves the whole building. 5. The load carrier sets the trade-offs, so always classify by asking what carries the load. Quick recall. All air carries the load in air, with big ducts and an easy economizer. All water carries it in water, with small pipes but a separate ventilation path. Air water uses a DOS for ventilation, plus a water terminal for the load, decoupled. The mixed air temperature is the flow-weighted blend at the outdoor and return air section. And the changeover temperature is the outdoor temperature where a two-pipe water system flips between heating and cooling. Golden rule: name what carries this own load, and the duct size, pipe size, ventilation, and economizer trade-offs all fall out of it. Next up, Lesson 11, Exam Strategy and the Week 6 Capstone. You now have all 10 building blocks: controls, valves and dampers, control loops and economizers, system types, codes, acoustics and vibration, piping, humidification, combustion, and this integration frame. Lesson 11 is a trap drill and a full-length problem set that ties it together. The Root 3 on three-phase power only, valve sizing versus cavitation, bigger deflection giving better isolation, plus 3 decibels for 2 equal sources, and simple payback ignoring the time value of money. Everything's at PEPrepEngine.com. Cheat sheet, work solutions, and a quiz attached here. If this course is helping you get ready for the PE, subscribe so others can find it too.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.